Anytime. There we go. All right. So we got a warm up today, right? The warm up was only asking you, and hopefully you guys are filling it out right now. Just determine if you can apply the mean value theorem or not. And if you can't, explain why not, right? Explain why not. So remember, let's go back on our notes real quick. How do we know if we can apply the mean value theorem or not, right? I'm going to go ahead and close you. You're in the way. Let's see here. How can you tell? Let's go back and look at our notes here, right? The mean value theorem is just something that ensures a value exists between a closed interval. And that value satisfies the conditions where the derivative or the slope of that tangent line at that particular point is going to be equal to the slope of the secant line that goes through the endpoints that you care about, right? But this is only guaranteed when two conditions are met. The first condition is that the function that you're looking at needs to be continuous on the closed interval. So that's the first thing you need to focus on. Is the function continuous on the closed interval? Not on the whole interval, just the closed interval that they're telling you to look at. The second thing is it differentiable on the open interval that's given there from A to B? So if the function is continuous and the function is differentiable, you can go ahead and say the mean value theorem applies, right? And there has to be a point that exists between A and B where the derivative is equal to the slope of the endpoints, right? Of the slope of there. So let's go ahead and take a look here, right? Looking at this function right here. The first one, x squared minus 9 over 4x. Is that continuous on the interval from 1 to 6? Well, remember, how can you tell if a function is continuous or not? It varies from problem to problem. So you can't just be like, okay, this is the end all give all if this is continuous or not. We're looking at this function right here. What I tend to do is break down what type of function this is. And if you look at it, it's a rational function, meaning it's a fraction, right? Fractions tend to have problems when the denominator is equal to 0. Looking at number 1 right here, I'm going to have an issue when x is equal to 0. Do you see that? When x is equal to 0, I'm going to end up with a 0 in the denominator there, which will make this a vertical asymptote pretty much, right? But here's the thing, is 0 part of the interval that we care about? It's not. The interval that we care about is only from 1 to 6. Since the interval is from 1 to 6, 0 is the only place I'll have an issue with. Everywhere else I can plug in 1 and I'll get a value, right? 1 squared minus 9 is going to give me negative 8 over 4, which is a value. If you plug in 6, you'll get 36 minus 9 over 4 times 6, which is just a fraction. And that's another value. So this is continuous, right? This problem is continuous on the interval. So that's a check for the first part. The second part is it differentiable or not? Is it differentiable or not? And you'd have to use the quotient rule for this one. Also, if use the quotient rule for this one, you know that you'll have low D high minus high D low over low low. But the issue is if you know what the graph looks like for this guy, the only part that it's discontinuous at is at x equals 0. It's also going to be not differentiable at 0. But again, 0 is not part of the interval here, right? So it is differentiable from 1 to 6. Yeah, and you can prove it by doing the actual calculation, by calculating the derivative, and you'll see, you'll have another rational function, and you'll see, oh, and you should practice that, by the way. It's good practice to do your quotient rules. But you'll see that when you do the derivative of this, you'll end up with something that has a fraction again, and the derivative, the only issue you'll have is when the denominator is going to be equal to 0, and that's only going to happen when x is equal to 0. So number 1, can you apply the mean value theorem? Simply yes, and you just tell me it's applicable because it is continuous and it is differentiable, and that's it. That's all you have to do. Just tell me yes, because it's differentiable and it's continuous on the interval from 1 to 6. Okay. Look at number 2. Look at number 2. Checking out number 2 here, we see that the denominator is going to equal to 0 at some point, right? And let's take a look at that real quick. I'm going to go ahead and scroll over to the side over here for our warm up today. And I hope you guys, let me go back and get that down here. X squared over 4x plus 8. X squared over 4x plus 8. We're looking at that on the interval from -3 to 1, right? So let's take a look at some of your responses here. How do you guys fill this out? What do you guys think? It is or it isn't? Yes or no? I don't know. what answers we got here, but I'm just going to click some. I'm just going to star some here. Let's take a look at some of your answers of what you guys think for the second one here. I'm just going to pick some at random here. Let's go ahead and take a look at some of these responses and see what you guys think. So first one up, let's see here. No, it is not continuous at x equals to -2, which is on the given interval, right? That's good. That's good. Let's see here. What we got here? Not continuous at x equals 2. It cannot be applied. Beautiful, beautiful. Mean value theorem cannot be applied here. X is equal to -2. The denominator will equal to 0, making that point undefined and not continuous on the interval from -3 to 1. So looks like a majority of people. Oh, this person's typing right now. I'll come back. I'm very confused. I also got another fraction form. I'm just going to go to student hours. That's fine. Don't worry. At least you're honest about it. You're absent for this lesson. That's perfectly fine. No, it is not continuous on the interval. That's right. That's right. A little bit more though. Tell me where. That would be awesome. Continuous? No. At x equals to, I believe, -2 is what you meant to type out there. As everyone else is saying, not continuous. Good, 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 good. Looks like everybody gets the idea here. X at x equals -2, it is not continuous since the denominator is, this is cool, 0. That's right. So how is everybody knowing that it's equal to 0 at x equals to -2 in the denominator? You just do the algebra, right? You just do the algebra. You set the bottom, 4x plus 8, set that equal to 0, or you can kind of see where it's equal to 0. If you can do that in your head, some people can. But I like to show my work, right? 4x is equal to -8. Divide both sides by 4, you end up with -2. And that's where you get a 0 in the denominator, which causes it to be not continuous at x equals to -2, which happens to be in the interval that we're looking at. If the interval was anything else that did not include x equals to -2, we could use the mean value theorem. But since it is the case, we can't use it. We can't do this problem. Okay? That's pretty much the idea for that problem, right? That's pretty much the idea for that problem. It is not continuous, so we can't do it. Now, if you can do the mean value theorem, sometimes the questions will actually ask you to calculate the value for C where the mean value theorem can be applied. So you actually have to find the value of C that satisfies the mean value theorem. So let's practice doing that today. So can you guys, I'm going to copy this down here, and we're going to do this one real quick on how to find the value of C, right? How to find the value of C. And it's mostly just some algebra. It's mostly just algebra. I'm going to scroll down a little bit here. Yeah, let's practice over here. So I'm going to go ahead and put this problem right here. So in your notes, right, if you guys want to work along with me, this would be great. Right? We've already said that we can do the mean value theorem because this is continuous, right? We checked it off for number 1. It was continuous, and it is differentiable. Right? It is differentiable. So that means that we can use the mean value theorem. Mean value theorem checks out. We can do it. So how do we use the mean value theorem? There's 2 things you got to do. You got to first find the slope of the endpoints, right? The slope of the secant line that goes through the endpoints. So remember, that's just going to be this guy right here. The slope of the secant line is going to be equal to f of 6 minus f of 1 over 6 minus 1, right? So let's do that real quick. Let's plug it in and see what we get. I'm going to do this off on the side. F of 6 is going to be equal to 6 squared minus 9 all over 4 times 6. Plug that into a calculator or just do the math out. 6 squared is 36. 36 minus 9. What is 36 minus 9, guys? Am I thinking this right? Is it 27? Is that right? I'm hoping that's right. Divided by 4 times 6, which is going to be 24. I do that right? I think I can reduce 27 over 24 by a factor of 3, right? So on the top here, we're going to have 9, and at the bottom, we'll have 8. You guys double check my math as I'm doing this. Let me know if I do anything wrong. I do have a tendency to make, small calculation errors here and there. Over here, if I plugged in 1, I'll have 1 squared minus 9 over 4 times 1. And that's going to give me 1 squared is 1, minus 9 is going to give me -8 over 4, which is going to give me -2. Okay, so the slope of the secant line is going to be equal to, let's see here, 9 over 8 minus a negative 2 all over 5. God, that's ugly. Let's do that real quick. Simplifying this out, this is going to be 9 over 8 plus, right, negative and a negative. And then I want a common denominator here. So instead of 2, I'm going to write that as 16 over 8. Right, and again, this is all being divided by 5. How you guys doing? You guys okay? You guys aren't getting tripped up by the algebra, right? You guys aren't getting tripped up by the fraction calculations or anything like that? This is going to give me 9 plus 6 is going to give me, this is going to give me 25 over 8, all divided by 5. Of course, you keep the top, you flip the bottom, you change it to multiply. So instead of 5 over 1, it becomes 1 over 5. And we simplify this out. This is going to be 5 over 8. Ugh. You guys doing all right? You guys doing okay? Have I lost anyone? You guys feeling all right? Did I go too fast with the calculations? If at any point this is too much for you, you can use your calculator to do this for you, and it will reduce your fraction for you. Just a heads up if you guys need that to have it to do this for you. So just a real quick thing, your TI calculator, the ones that you guys have on your Chromebooks and the ones that you guys have in person, I just wanted to show this for you. There is a cool feature here that will do the calculations for each of these parts for you. So you can type in the function that you're dealing with here. Make sure when you type in the function, you have parentheses with it. So I could have something like this, x squared, right? Minus 9, and this is of course in the numerator, so I'm going to close that off in parentheses, and then this is being divided by parentheses 4x. Right? I can type in my function into here, right? And once you have your function typed in, notice it's typed into y sub 1. If you have an 84 plus or higher, this is the part that's kind of neat. 83 plus can do it too if you updated the ROMs, but I don't know. Is any of you guys, I don't know if any of you guys are using the 83 or not. But if you guys are just using the one that's on your Chromebook, check this out. You ready for this? I can actually just go here and hit alpha and then trace, and you see how they have this little menu bar comes up and it says y1 to y sub 0. y1 is where I stored my function. If I call on that function and I plug in the value that I want to plug in this case I want to plug in 6, right? It will do that calculation for me, right? 1 over 1.125. Guess what? All the calculations here are done in fractions. Your calculator can actually calculate the fractions for you. If you just hit math, you'll see this option right here that says frac, it's short for fraction, and you can tell it to turn your decimal into a fraction for you, and it will even reduce it for you. You see that? 9 over 8 is exactly what I got over here. Isn't that neat? You can do it again, right? Check this out. Go to y1, and I can say, oh, hey, can you do me a favor? Plug in 1 for me, right? And it'll give me this guy, which is what I got over here. Now, check this out. I can just plug in this whole entire statement right here. You ready for this? My numerator is, whoops, I did not mean to graph that. Second quit. All right. So check this out. If I go ahead and hit alpha there, and then go ahead and type in y of 6, right? Minus alpha there, and it's going to be y of 1. I can take this thing and divide it by, in the bottom, 6 minus 1. And I get this guy right here, which is a decimal. But again, we can go ahead and turn that into a fraction. And I get there 5 over 8. Brian, shouldn't it have been 25 over 8 times 5 because of the reciprocal? Yeah, so that's the part that's trippy when you deal with fractions over fractions. This 5 is technically 5 over 1 in the bottom there. So when we do the reciprocal, we're flipping 5 over 1 to become 1 over 5. Yeah, I know. It's one of those things just kind of like, yeah. But check it out, though. We figured it out. We solved it, right? And I just wanted to show you, this is a cool thing you could do with your calculator, right? You can actually have it calculate the slope for you if you have the function typed in. So if you type in the function into y equals, right, and whatever function you're dealing with, you can actually have it calculate your slope for you. just by telling it, hey, where am I evaluating it at? Divided by the x values, subtracting each other. Anyways, that's that part right there. The next part you need is the derivative, right? Once you have all that down, we need the derivative here. So let's go ahead and calculate the derivative here. I'm going to go ahead and use the quotient rule for this one. You could rewrite it and use the product rule, but I think the quotient rule is going to be a little bit easier, right? I got my low. Knock me. I got my high right here. I got my low right there. So the quotient rule is telling me low d high. So the derivative of the high derivative of x squared is just 2x minus high, which is x squared minus 9, d low, which is 4, all over low, which is 4x squared. There is my derivative using the quotient rule. But since I'm going to be setting this equal to a fraction, I'm going to try to simplify this out because I can't just leave it like that to solve it, right? So let's simplify this out. 4x times 2x is 8x squared. This is going to take a little bit of work here. 4x squared minus 4x squared. And then 4 times 9 is 36, but it's a negative and a negative, so it'll be plus 36. I hope I did that correctly. Again, let me know if I'm doing any calculations wrong here as I'm working my way through. In the bottom, I have 4 squared, which is going to give me 16x squared. Does that look right? Did I miss anything? Is there any cubes or anywhere that I might have missed? Let me know. Let me know. So this is telling me y prime is equal to 8x squared minus 4x squared. Those are a common term right there. So I can go ahead and combine that. 8x squared minus 4x squared looks like it's going to be a 4x squared plus 36 all over 16x squared, right? And I can reduce that. That looks like it all has a factor of 4. So I can reduce that down further and say y prime is going to be equal to x squared plus 9. And in the bottom, I have here 4x squared. And there is my derivative. Did I do that right? Does that look okay? Anyone want to double check? Make sure that I did that correctly. I hope I did that correctly. I hope. Now, the mean value theorem, you're not done just because you found the derivative, right? The mean value theorem is saying that there is a value of c where the derivative is going to equal to 5 over 8. 5 over 8, of course, being the slope of the secant line, right? So I need to solve this guy right here. Do you guys remember how to solve this? This is not calculus anymore. This is, if I'm being honest, this is like algebra 2. Oh, wait, you guys don't take algebra 2 anymore. This is like IM3, right? IM3, solving this rational expression. You guys tell me, what would you do to solve something like this? What can you do? What's something we can do? I know some of you guys don't like fractions. Is there anything we can do to get rid of these fractions? Anybody know? How could I solve this? Any ideas? It's been a while since you've done some algebra work, huh? Some IM3 work, integrated math. Multiply it by its reciprocal. Very close, very close. I mean, you could, yeah, actually, that might work. But then you'll end up with a fraction still, won't you? So there's a shorter way for this, and that's pretty much it. You have a cross multiply. Cross multiply. If you cross multiply, you'll get rid of the fractions, and it might be easier to deal with, right? If you multiply by the reciprocal, you'll cancel this out, and it'll become a 1, but then you'll have a massive fraction on the other side. And that's not wrong. You'll just end up doing a little bit more work, and you'll eventually get there. You eventually get there. But what I'm saying is, if I multiply both sides by 8, like this, right? It'll cancel out these 8s right here, and then this will become a nice fraction. I distribute this 8 up here, like so. But then at the same time, I want to get rid of that 4x squared, so I multiply both sides by an additional 4x squared, and this side by 4x squared. Let's move that out of the way. That way, over here, this cancels out with this, and you're left with just whole numbers. And that's what cross multiplying is in a nutshell, but you guys might have learned it this way. Hold on, let me write it this way out. So maybe you'll be more familiar with it. Traditionally, most people see it this way. When there's an equal sign, you are allowed to cross multiply fractions. That way you don't have to deal with fractions anymore. Right, so over here you can have 8x squared plus 72 is equal to 20x squared. Right, now you have a quadratic, but there is no b term. Right, so you could use the quadratic formula, but since there's no b term, I could just isolate the x squared term. and take the square root of both sides, right? There's multiple steps on solving quadratics, and I hope you guys remember that. You could, like I said, you could set it equal to 0 and use the quadratic formula, or you can hope that it factors. That's another way of doing it as well. I'm just going to set it equal to x squared, and then hopefully I can get it by itself and take the square root. So subtract the 8x overs. I got 72 is equal to, it looks like 12x squared. Divide both sides by 12. I end up with 72 divided by 12, I believe is 6, right, is equal to x squared. Take the square root of both sides. When you take the square root of a variable, though, you have to make sure you include that the answer is going to be plus or minus the square root of 6 is equal to x. And I need to double check, is that on my interval? Remember, my interval is from 1 to 6. The square root, the positive version of the square root of 6 is on that interval. Negative version of square root of 6 is not on that interval. So this is not one of my answers. My only answer is C equaling to the square root of 6. Meaning, if I were to graph this function and I drew a secant line from 1 to 6, and I went to x is equal to the square root of 6, I will see a tangent line on the function that's parallel to that. That's all the mean value theorem is saying, is that there's some value in between the two endpoints that's parallel. When you draw the tangent line, it will be parallel to the secant line that connects it, right? That's all that's saying, and that point exists. And you can actually do the work to calculate it, but I don't think that's as important. I think understanding the fact that it does exist is a bigger part. Finding it, this is simply just algebra work. And honestly, the algebra is not something that you learn in calculus. It's something that you practice. It's something that you have to know how to do from your previous classes. But it takes a lot of time and a lot of patience. But again, the important factor is that this point right here, you can prove that it exists. And then the algebra work will show you to find it. That's all it is. Okay? So that's the mean value theorem in a nutshell, guys. Proving that a point exists, proving that it's there. And let me show you this real quick. I did this last time, but let's do it real quick again. I just wanted to show you guys Desmos, because Desmos, like I said, is an amazing tool. All right, let's go over here. Check this out. Check this out. Right, the function that we're working with, right, is f of x. Let's call it that. Is equal to let me see here. What was it? X squared minus 9 over 4x. X squared minus 9 over 4x. So we have here x squared, right, minus 9. This, of course, is all over 4x. And that's what this graph looks like, right? It looks something like that. But we only care about it on the interval from 1, f of 1, whoops, which is that point right there, and to 6, comma f of 6. You guys liking my Desmos skills here? You see this here? It's amazing. So we're only focused on these 2 points right here, right there, right? Now, I can go ahead and draw a secant line that goes across that right there. So let me see here if my skills are still as good as they used to be. Let's see here, y minus, let's see if I got this. Y minus 1 equals, this is going to be a fraction, f of 6 minus f of 1 over 6 minus 1. Close that off, and this is, of course, multiplying with x minus f of 1. Did I mess that up? I think I messed that up. Dang it, knock me. How did I mess this up? It's supposed to be going through, this point. Oh no, I messed up somewhere. Why is it crossing through there? Oh man, I'm gonna have to go back and check this again. I messed up on this. This line's supposed to be down here. If I use 6 instead, will that work? That just goes higher. Oh, whoops, I'm an idiot. The y value's over here, knock me. X value's over here. There we go. Oh my God. All right, so there's the secant line. There's the secant line, right? There's the secant line. And of course, right, that secant line is equal to, right, is equal to 0.625, which in other words is equal to what we found out it to be, which is 5/8, right? 5/8. So 5/8 is that value right there, right? And if you draw a tangent line, right? If you draw a tangent line at the square root of 6, check this out, y minus f of square root of 6, close that off, is equal to f, the derivative, at square root of 6. Oops, almost done, I promise. Apply this with x minus the square root 6. Boom. There you go. And let's go ahead and make that a little bit thinner. Is it this value? This one, opacity? No, I want the thickness of the line. Let's make that a little bit thinner. Let's go with 1.5. There you go. But check out right there. That's where it's crossing at, right? That's where that tangent line is. It's, oh wait, no, it's over here. There it is. The tangent line is right there. And you see the line is parallel to that one. That's all the mean value theorem is having you do. It's having you find on this closed interval from 1 to 6, right? From 1 to 6, a line that's tangent to this function and parallel to the derivative is parallel to the secant line. I know that I spent way too much time on this, but I tend to do that. I don't know why. I like looking at it. It's just kind of cool. It's guaranteed that you can find it as long as the function is continuous on the interval and differentiable on the interval. You are guaranteed to find this spot. All right. That being said, can you guys let's practice this a little bit more. Can you guys try doing this one right here? Try this one right here. Find the values of C that satisfy the mean value theorem for this one right here. So first thing you got to do is check if you can even apply the mean value theorem, right? Which I'll let you know that you can, right? What are the two things you need to find? You need to find out that it is continuous and that it is differentiable. So go ahead and do that real quick. You can do this on paper and then just give me the answer on the pear deck for me. But let's go ahead and give you guys, since we're doing some algebra and the algebra is taking a little bit of time, let's set you guys up with, let's go with 3 minutes, see where you guys are at in 3 minutes. Go ahead and give this a shot. Okay, let me see where you guys are at. I'm gonna go ahead and set a 3-minute timer. Boom, and then you guys go ahead and try this as best you can. I always end up wasting way too much more time on Desmos than I wanted to initially, but I can't help it. Desmos is just too cool. It's just too cool. If someone wants to work out the steps for me, I'll give you extra cardinal points today. If someone wants to work out the steps onto the pear deck for me, and I can just share yours, and we can take a look at it that way. It is going to require a little bit of solving quadratics. Oh my, it's already 10:07. How have I blown so much time? That means we got like, how much time we have left? We have about 30 minutes left. Okay. Okay. We can do this. Double checking attendance, by the way. It looks like I got everybody joining except for Mark. Mark, I don't see you in here, so let me know if you are in the chat. Type in the chat. If not, I'll just have to mark you absent. Do. Good. Some of you guys already noted that you can apply the mean value theorem. That's a great start. Yes, yes, yes. Good start on finding the slope of the secant line. Looking good, looking good. I think we need a little bit more time. I'm going to go ahead and reset that. I'm going to go ahead and reset that. It looks like we need a little bit more time. Good. Keep working it out, guys. Keep working it out. We're on the pair deck. Let's see it. Let's see it. Oh, a couple more people started to type in some answers. We're getting a couple people are getting the same answers for the slope of the secant line. A couple people are getting some different answers on the slope of the secant line. Good, good, good. I see you guys working it out. Good. All right. Looks like we're taking a little bit more time than needed. So, I'm going to go ahead and stop that there. And let's take a look at some of the starting of this right here of what you guys have. So let me star some of these answers here and share what we have so far. Okay, share what we have so far. Haha. Oh my. All right, so let's take a look at one right here. Interesting. So this person's still working out, but this is the part I wanted to make sure you guys see, right? Before you actually start doing the problem, which, by the way, this person did it beautifully. You are working out beautifully. One thing that I would ask you to do is to please state that you can do the mean value theorem. I know this seems like a weird, like, why do I need to do this? But you got to show me that it's continuous. You got to show me that it's differentiable. And literally, you don't have to do much other than just write it down and say that it is, because most of the problems, when they are, it's I don't want to say this that it's obvious, but it's something that you have to put that extra effort into doing. So check this out. Person who I was showing, it was done beautifully, by the way. Your work was done beautifully. But please don't be lazy. Take that second, right? Take that second and just state that it is continuous. right? It is continuous, right? And that it is differentiable. And you know, if you want to go above and beyond, you can say it's continuous on the interval from 0 to 3, and that is differentiable on the open interval from 0 to 3, right? Some teachers are very picky. Some professors are very, very picky about this, and they actually make you prove it by writing things out and whatnot, but that's going to be later on down the lines. For right now, it's easier to prove it when it's not differentiable or if it's not continuous on that interval. If it is, just kind of write that down and put a check mark. And if it's not, just show me where or give me a value that it's not, right? But if it is, just kind of write that down just to get this off. So then you can say mean value theorem does apply, right? You put a check mark for me. I'll take that. Now, once you do that, you got to go ahead and find the slope of the secant line for me through the endpoints, right? Which is going to be f of 3 minus f of 0 over 3 minus 0, right? And if you were doing this out, it looks like the slope of the secant line, you should have gotten 0. You should have gotten 0. And if you need work on that or practice on that, right, just try doing the calculations. F of 3 is going to give you, I believe, 4. And then if you do f of 0, that's going to give you, I believe, 4 as well. So that's why you end up with 4 minus 4 in the top. And in the bottom, you end up with 3 minus 0. So you end up with 0 over 3, which is just 0. All right, so that's what the slope of the secant line is equal to. The slope of the secant line is just equal to 0. The derivative of this function, y, is going to be equal to, take the derivative of both sides here. We end up with 3x squared minus 6x. And we're just looking for when does this thing equal to 0. Equal to 0, right? You can solve this by factoring, I would say, right? By factoring, you have a 3x that factors out. You're left with x minus 2, right? And this is going to be equal to 0. And I end up here with two values here. X is equal to 0 or x is equal to 2. And I'm going to leave it here for you guys to ponder. We know that x equals 2 works, right? Is in that interval. I'm going to let you guys wonder or not, is this going to be a valid answer? Does this one satisfy the mean value theorem as well? Is that on the interval that we need to include with it as well? I'll leave you guys to it on that one. Okay, but yeah, that's the mean value theorem in a nutshell. So hopefully you guys are okay with that and you guys get that down. Okay, I'm going to go into our notes now. Let's go ahead. I'll give you guys a second to copy that down. And then we're going to go into our notes. We're going to finish up. We already finished up mean value theorem. I want to talk to you guys about a specific case of the mean value theorem, and then wrap up this part of it today. I took way too long on explaining this. This was supposed to be done like earlier. I don't know why. I just like talking too much, I think. All right. You guys got this down? I'm going to go ahead and scroll off. If not, you can always go onto the OneNote notes on your Canvas page, okay? You can always copy it from there. All right, so let's go over here. Let's talk about a specific case of the mean value theorem. And this always gets me a little bit, not heated, but kind of like, man, kind of unfair. I know it's like, I shouldn't be thinking that way, but look, you'll see it right here. This guy got a theorem named after himself, and this is all he did. This is all he did. Rolle's theorem is just a special case of the mean value theorem, right? Meaning that first things first, the function, right? The function that's you're talking about, f of x or whatever, needs to be continuous. So that's the first one. Let's write that down. Rolle's theorem is a special case where these three conditions are met. The first condition is that the function needs to be continuous. On A to B. On A to B. Number two, the function needs to be differentiable. On the open interval A to B. It's already pretty much the same thing as the mean value theorem, isn't it? The first two conditions there is exactly what the mean value theorem is. Third condition is this. Third condition is this. The endpoints need to equal each other. F of A needs to equal to F of B. The mean value theorem then states that there is a derivative at some point C that's going to be equal to 0 for some value C that is in A to B. And that's exactly what we just did on that last problem, isn't it? F of 0 was 4, and F of 3 was also 4. So we ended up with the derivative, the secant line being equal to 0, which just shows that, hey, that means that in between there should be a derivative, a tangent line that's also equal to 0. So what does that look like? All right. If I have a function right here that's drawn like this, right? And let's say A is over here and B is over here, I could have it look something like it starts up here, goes like that, and then comes back to here, right? And what I'm saying is, if F of A is equal to F of B, this point right here, the secant line that you draw is going to be straight across. All Rolle's theorem is saying is that in between, there should be at least one point where you have the tangent line that's parallel to it also equal to 0. Which is like well, duh, because that's what the mean value theorem states. This is just a special case. The special case being that the endpoints equal each other. The function value at the endpoints are equal to each other. And I hate this fact. Like, this guy got this theorem named after himself, and all he did was just did one more point. And I was like, huh. All right, this is just the mean value theorem with extra stuff. And that's extra stuff is just one extra thing. Guy got him named after him. But that's it. That's all the Rolle's theorem is. It's a special case. It's just showing you, like, hey, the derivative is going to be equal to 0 because the endpoints are equal to 0. No matter what, no matter how you draw this out, if the function looks crazy or whatnot, if the endpoints end up having the same value, can you guys picture it? There's no way. There's always going to be existing at least one tangent line that's going to be flat as well. That's the only way for that to happen. Because if you have, for example, right, let's say your endpoints are F of A and F of B are like this, and it goes up and then back down. The fact that it changes directions to come back down to match right here gives you something that has to be parallel. And if you draw it another way, instead it goes down and comes back up like this, it has to also change directions right there. So it has to go back up to meet up at this point, which causes it to flatten out right there. As long as the function is continuous and differentiable, that's always going to be the case. All right, as long as it's continuous and differentiable, there's no way to go from one point A to point B if they're at the same without this happening. There's no way you can draw this line from here to here, no matter what, as long as it's continuous and differentiable, without having a point in the middle or somewhere in between there that is going to be, the derivative is going to be flat. Okay, so that's that. So that's the Rolle's theorem in a nutshell. That's Rolle's theorem in a nutshell. Right? So the steps on doing this is the same thing, except now you just have a third thing to check, right? So when you're doing a problem like this, if you guys could write this down, right? Here's a function, and find which values of C for which Rolle's theorem applies. So in order for Rolle's theorem applies, you got to do three things to check off now. Check if it's continuous. And in this case, it is continuous from 0 to the square root of 3 because there's no holes, there's no discontinuities at all, right? It is continuous. Is it differentiable? Is it differentiable from 0 to the square root of 3? And it is. It is. You can take the derivative of that, right? There's no problem with that. There's no holes or anything. Again, you don't have to worry about. But the last one is this one now. The last one is this. In order for you to do Rolle's theorem, you have to check out what f of 0 is equal to. And f of 0 is going to be equal to, plug in 0 here. You end up with 0 cubed minus 3 times 0 minus 2. We end up with negative 2 as my answer for f of 0. And then plug in the square root of 3. So I have here the square root of 3 cubed minus 3 times the square root of 3 minus 2. And what does that equal to? Well, square root of 3 cubed is going to give me 3 square root of 3 minus 3 square root of 3 minus 2, which of course that's just equal to negative 2. So this is the last part right here. You got to prove. You got to prove to me that f of 0 is equal to f of square root of 3. And that checks out. Since that checks out, these are the three conditions that you need. 1, 2, 3. If those all three check out, you can say, hey, Rolle's theorems apply. That means, therefore, Rolle's theorem applies. Therefore, f prime of c, there should be some value of c such that this is equal to 0. And then we just do the algebra part again. And like I said, the algebra part is the part that's not as important as the calculus part, which is you can prove that that point exists. Finding that point, that's not even calculus. That's now your algebra skills being tested, right? So I need to find the derivative. So y prime is equal to 3x squared minus 3. I can say that this has to equal to 0 at some point, and we just solve this out and see where does it equal to 0. So I have here 3x squared is equal to 3. X squared is equal to 1. The square root of both sides part of this becomes plus or minus. So I have here x is equal to plus or minus 1. But the only one you really care about is the one that's on the interval. -1 is not on the interval, right? X equals to -1 is not on the interval. So the only one we care about is x equals to 1. And that is right there your answer. So that if I were to graph this and I looked at x equals to 1, I'll have a tangent line that is equal to 0, right? The slope of that said tangent line is equal to 0, I should say. The slope of the tangent line is equal to 0. All right. That being said, that's all Rolle's theorem is. It's a very quick, very straightforward thing to do. That being said, let's wrap this up. Some of you guys who are doing homework might have realized you came across a couple problems that were talking about increasing and decreasing behavior. When is the function increasing and when is the function decreasing? And what I wanted to tell you this is there's actually an easier way than just graphing it out. You can actually do this numerically, but let me show you real quick. I'm going to waste some more time for you guys on Desmos again. But, you know, Desmos, it's fun. Let's go to Desmos. Let's get a clear one right here. And let me graph a function here. Let's say f of x, right, is equal to x minus 3, x plus 4, x minus 2, and what the heck, let's throw in an x in there. No, that's too much. That's too much. Yeah, that's too much. Let's go with this cubic right here. So here's my cubic, right? Here's my cubic. You guys see that okay? So check this out. Let's make this a little bit better. Let's go from, this is going to go from -8 to 50. And let's have the x-axis go from, let's go with -8 to 8. Let's go with that. There we go. That looks a little bit better. So you guys can see this a little bit better, right? No, so when you graph it, you can clearly see when is a function increasing and when is a function decreasing, right? You guys see this? The function is clearly increasing from this left side right here all the way up to this point up here, right? And then it's decreasing, right? When they say a function is decreasing, that means we're reading this from left to right, right? And it's decreasing meaning that it's going down from left to right. So it's going down from that point right there all the way down to here, where it stops decreasing and now it's just 0. And then it starts to increase everything after that. Now, how can you do this without graphing it? Very simple thing here. Let me show you what I'm trying to have here. If you were to graph its derivative, check this out. There's a really neat thing that happens here. Focus on this point right here. Do you guys see this point up here? It's -1.852. Check this out. If you look at the derivative, look at where it crosses the x-axis. It crosses at the x-axis at the same value as it is up here. And that's because of Rolle's theorem, right? The derivative equaling to 0 means that we have a flat tangent line up here, right? We have a flat tangent line up here. But check this out. What do you notice here where the graph is increasing? The graph is increasing from here to here all the way up to 1.8. Look at the blue graph. What do you notice about it? The blue graph is above the x-axis. The derivative is positive here. And when your derivative is positive, what do you notice about your function? Your function is increasing. So whenever your derivative is positive, that means your original function is increasing on that interval. If your derivative is below the x-axis, which it is down here, right, which which means then that the function is decreasing. When your derivative is negative, your function is decreasing. So in your notes here, I need you to write that down. When a derivative is negative, the function is decreasing, right? When a derivative is positive, the function is increasing, right? And that's kind of neat. It's basically telling you could find out if a function is going up or going down from left to right without even looking at the graph. You can just look at its derivative. When you take the derivative and you evaluate it at that particular point and that derivative comes out to be positive, that means the function is increasing on that point, right? So if I were to look at this, like I said, if I was just looking at this random point right here at x equals 0, right? The derivative value at x equals 0 is negative 14. That means that the tangent line right here has a slope of negative 14. But of course, you can kind of see that the function itself, as it goes through that point, is decreasing, right? So in your notes, can you guys make sure you get that down? The derivative, when a derivative is negative, the function is decreasing. When the derivative is positive, the function is increasing. And the same can be said the other way around. When a function is decreasing, its derivative is negative, right? Is negative. When a function is increasing, its derivative is positive, So can you guys get that down? It works vice versa for that as well. When a function is decreasing, its derivative is negative. When a function is increasing, its derivative is positive. Okay, that's pretty much it. All right, a couple things I want to wrap this up with is I have the second part of the homework for the mean value theorem posted onto Canvas. Let me show you that real quick. So let's go ahead and open this up over here. So right there, the second part of the homework is on there. I was going to do a Desmos activity, but we do not have time for that today. So I'm going to cross that out. So we talked about Rolle's theorem, increasing, decreasing behavior. The second part of the homework is going to be posted up. It's already posted up, so you guys can start on that as well. So the first homework should be done and turned in by hopefully like today or Wednesday. I'm going to go ahead and grade that. And I think you guys agreed with, I think you guys were the ones who also wanted it, like if you guys wanted me to put in zeros, right? If you don't do the homework on time, I believe is what you guys asked for. That doesn't mean that I'm going to lock the assignment. That just means that you can see what your grade is real time, and then you can still turn it in. And you can turn it in for full points still. So I will still accept the late work, but I'm going to put it in as zeros if it's missing, just so you guys can see your true grades, because that's what you guys wanted. That way you can see where you're at, and you can do the assignment. You can actually see your grades go up and down. Calvin's like, no. Max is like, no, you guys will be fine. As long as you do the assignments, even if it's late, I'll still give you the credit for it. Okay? Even if it's late. There's a couple of new things I wanted to talk to you guys before I wrap this up today. Last semester, I didn't get to give much points on participation. I want to start changing that up. I'm going to have some more participation stuff assigned for you guys. And the first thing that's going to be up is I'm going to be a little bit more proactive on the AP Classroom stuff. So I'm going to start assigning some participation stuff for you guys to do aside from the homework. Right? This will go into your participation grades, and participation grade only makes up 10% of your grade, right? Your homework is 30%, your quizzes are 30%, and your tests are 30%. The last remaining 10% is going to come from your participation points. And one of the things I'm going to do for participation is, interesting, is going to be checking to see how many of you guys are looking at have you guys watch a video here. So first things up, I think we're on unit 5. Yeah, I jumped around here. So for example, for the mean value theorem, right? I'm going to assign these videos, and for participation points, very easy. I'm just going to see if you've watched it or not. So you guys can see here, I can actually click and see what's the percentage of people who watched this in this period, and no one has watched it yet because I haven't assigned it yet. So I'm going to go ahead and assign this. I'm going to assign mean value theorem, right? Assign this to all my classes, which is period 3 and period 4. I'm going to assign that one, the second one, assign to all my classes, and assign this one right here the third one. So these are going to be on top of your homework problems, right? So they're about 7 minutes long each. I'm not expecting you to watch them all in one go. Just, whenever you have 7 minutes to kill, just push play, just hear them out, watch it, see his examples. And once you do that, you guys will have some practice questions to do. So I'm going to go ahead and assign this as well. Okay. So let's go ahead and assign these problems real quick here. Yeah, we're gonna just do, for this one right now, we're just gonna do the mean value theorem. So I'm gonna do let's do a couple of these. So this is mean value theorem topic questions. All right, so let's go ahead and create that quiz. I'm not done yet, buddy. I wanted to add that one. Let's add you, and add you. So they're multiple choice, by the way. Don't stress out on these. These are all multiple choice questions just to have here. So let's go ahead and do that. All right, 4 questions, multiple choice. I'm gonna go ahead and assign this. Start date, let's have the due date super far. By which I mean 1 week. Let's go for 1 week here. It'll be due at night. Actually, I need to set it to the next day because it's Eastern time. Dumb thing. So we'll do that online. We'll set a timer for this. 4 questions should take no more than 10. Let's do 20 minutes. No more than 20 minutes. Okay. So those are the things I'm going to be asking from you guys. Okay. So you're going to have to do this quiz. Not really a quiz. This is topic questions, right? This will be graded on completion. You're all right, Monica. This is for participation only. When we do actual quizzes, those will be graded for an actual calculated grade. For things on the AP Classroom, this is AP level questions, so they're a little bit more difficult. So this is going to be based off of completion only. When we do quizzes on Canvas, those are the ones that will be graded based off of correct answers or not. So everything that I put on the College Board right here is strictly just for participation points. It's an easy 10% of your grade, and it's based on completion. So it's supposed to, yes, Max, that's it. It's supposed to help your grade as long as you complete it. All right. Watch the video. I go through and check it if you watch the video, and then answer these questions on there. So 10% of it, I'll put the link into here later on today. If you go onto your AP Classroom, though, you should be able to see what's already been assigned. So I have the little arrows here. For you guys, it will be a to-do list pretty much for you guys to see it. 5.1 videos. It's just basically the mean value theorem. Okay, so that's that one right there. And I think that's it, guys. That's going to be it for today. Please make sure you finish up the homework from last week. Start on the homework for this week. And then if you have that spare 7 minutes, go watch the video on College Board and then answer the topic questions as best you can on there. Okay. Other than that, that's going to be it for me today. I have office hours today from 1 to 2, of course. Please stop by if you have any questions on the algebra stuff. If you have any questions on the mean value theorems, any calculus level questions as well. There's no question that's too dumb, right? If you feel like you don't know how to do something, please stop by and ask me for help. All right, guys, that's going to be it for me today. Let's wrap it up there. Have a good rest of your day. I'll see you guys on Thursday. All right. See you guys later. So long.